Okay, so what is this? I mean, what I had said yesterday, you just add. Come on, the title of the paper is Attention is All You Need. Okay, so and this is actually we can call it, this is cross attention. Right? So this is actually cross attention. And cross attention means, so this is same as before, just that here you had just multi-head attention, now here you have masked multi-head attention. Okay. Now this one is multi-head attention, but you are doing it cross. So what will be passed here? I have 5 and 2 outputs here. But what will be passed here? So you want to take attention. Okay. What will actually be passed? See, for attention you require Q, K, V. So what you will actually pass is, so you will have Q from here. Remember the encoder decoder architecture for RNNs. Your query was coming from decoder, and key and values were coming from, एकदम ही गायब सब. So in decoder you had queries. Remember it now? You had queries in the decoder and key and values were coming from encoder. But in that case, key and values were basically the same vector that we had called H, and it was S in case of decoder, right? So you had S, which was the query in the decoder, and what else? H were the key and value vectors which were coming from the encoder, right? So here what we are supposed to do is, this is cross multi-head attention, and we simply don't pass this and add it. What we actually do is, you take, so queries will come from where? You should be able to guess this now. Queries should come from where? Decoder. Okay. So let me just write this down. If that was 6x, this is also 6x. Do they have to be same? Of course not. Okay. Now, so query is coming from here. Here, in when you are doing cross, see, self attention means in that same thing you are going to take attention. What is cross attention? Query comes from the decoder, but values and keys will come from the encoder. So what you actually pass here is our keys and values. Query will attend to all those keys and values. So in this case, what are you going to do here? Should not spoil this. What are you going to do here at this attention layer? See, if this were self attention, what will we do? We will compute 3 vectors, Q, K, V, and we will compute, what was that equation? This one. Okay. And this is what we exactly do in case of cross attention as well. Just that V and K, they will come from encoder. So what is encoder actually passing? These values. Okay. So Q is from my decoder K and V come from encoder. What will be the output size still? Nothing changes. If you were doing so nothing changes, your queries are coming from here, K and V's are coming from there, that's it. Okay. Is this done? Okay. So that's why it is cross multi-head attention, and now we are done with the architecture itself. What is this linear doing here? See, it is because of this linear I had said this is extempore, because I don't remember the size of this linear, but this does not matter. Yes. What are we supposed to do now? Find the number of parameters in this. How many number of parameters now? This you can do it. So shall we do it here or on a different space? Okay. Okay. Now, so what happens? Where should I start from? Where are my first parameters? And I don't remember whether they train for word embeddings or not. But does it matter? So let me see. So आज की क्लास लंबी जाएगी भाई. Anyway, let us start and then we'll see. Yes. So what happens in this multi-head attention? Guys, what happens in this multi-head attention? So these are 512 dimensional thing. And I am assuming right now, I can change it later, I am assuming right now that we are not learning these word embeddings, they are coming from somewhere, right. So, right now I am saying they are not the part of the parameters, and I hope they actually are not, okay, but I can change that later. So, multi-head attention, what are the things going on here? QKV, what were the dimensions of QKV? So what were you doing? In order to compute, right, so in order to compute Q, you were doing W, Q, what we were doing Xi, right. Now, this Q was of size, so this is something we had done everything there. If we were doing everything at that same time, it was much better. This was 64 cross 1, this is, so this is now 512 cross 1, this guy has to be 64 cross 512, so that gives me the dimensions of WQ. So WQ is this, WQ, WK, WV, they are all, so this is basically 3 This is basically 3 cross 64 cross 512, and this is for one head. You have how many heads? 8. Make sense? Or am I missing something? Is this part over? Because then you are going to just compute. What was the equation? Huh. Yes. Okay, we are trying to find the total number of parameters in this whole thing. So this is this fine? 3 cross 64, see each one is 64 cross 5 and 2, and there are 3 of them, so cross 3, and this is multi-head attention and there are 8 heads. Okay, so this is done. What about add and norm? How many parameters here? So I must be writing this somewhere. This is which attention? Multi-head attention. Encoder, and we are talking about multi-head attention. So how many parameters here? How many parameters here, bhai? Same number? Yes? 0. You just add from here. So you add this one and you add this one. Okay? And then you normalize. So you have no parameters as such. If you want, you can put a couple of parameters here, but no more than 1, 2, but I won't go into that. Okay? So for us, there are no parameters here. So add and norm 0. You can put here, see in deep learning you can do whatever, but I am keeping it 0. Next. What about F, F, N, N? What about this guy? In this case, what I receive is 512, what I output is 512, and the middle layers are 2048. So this is straightforward. I have 5 and so the way we write our parameter matrices, it is number of parameters in layer L plus 1, sorry, number of neurons in layer L plus 1 cross number of neurons in layer L. So how does this guy look like? Remember, how does this guy look like? This is nothing but 512 here, 2048 here, and 512 here. So this is 2048 cross 512 in our convention, because we multiply this with this. So this is what does it give me? 2048 cross 512. What should I do with this? Multiply by 2. Multiply by 2. In fact, for this layer I should also add 2048, even though they are not so significant, but let us add them. Now, what about the next layer? So, instead of writing it here, so plus 2048 plus, so 512 cross 2048 plus 512. Now, as they say in the paper, they take nonlinearity, which is ReLU, only on this layer. Here they do not take nonlinearity. Okay. I had in one of my earlier lectures had said you can take ReLU at both of these, which you still can, but in the paper they do not do. But this does not have any impact on the number of parameters. What next? So, add and norm 0. So, that I am not going to write again. So, what is the total number of parameters in an encoder, in single encoder? Can somebody multiply this for me? Calculator use kar lo. So, this is going to be 8 into 3 into 64 into 512. Okay? कोई कर रहा है? हाँ. 8 into 3 into 64 into 512 plus 2048 into 512 into 2 plus 2048 plus 512. So, this comes out to be 2.8 million. So, let us just write roughly 2.8 million. Now, how many of them are stacked over each other? 6. So, total number of parameters in my encoder W in encoder is 6 into 2.8 m, which is multiply करना एक बार. I just want 6 into 2.8. 16.8. Okay. So, encoder is done or something remains? I think this is over. Now, let us talk about this. In this passing, are we doing any parameters here? In this particular connection, do we have any parameters? So, here you are passing keys and values, as such there are no parameters involved. What about this masked multi-head attention? What about this case? What is the equation that you write? Q plus M. Okay. And is that M parameters? That is a fixed matrix of zeros and minus infinities. It is basically a matrix that is upper triangular or lower triangular? Upper triangular, right? And then all values are same as minus infinity. So, that is not my parameters. My parameters are still Q, K and so my parameters are still Uh, what do I do? Same, exact same math for the calculation of number of parameters. It is still 3 cross 64 cross 512, and these are multi heads, right? What else? So mask multi-head is done. Add and norm again 0. So in this case we have 3 into add and norm equal to 0. What next? We have cross multi-head attention. See, I am computing Q transpose, is that right? Q transpose, what was the equation? Softmax Q transpose K divided by under root dk, and then this whole thing, the softmax of this thing multiplied with V. So this is fine. Now what happens here? Your Q's are coming from the decoder. How will you compute queries? So for cross multi-head attention, how will this guy look like again? So the number of parameters will still be the same, or will they change? See, what is changing here? Just that queries are coming from decoder and values and keys are coming from encoder. That is the only difference. So, so what we do here is 3 cross 64 cross 512 8. This should make sense. Okay. What about the last one now?
0.
No, so 3 into add and norm is 0. FFN, same thing again. What was there for FFN? So it was FF and N, it was 2048 cross 512 plus 2048 and now plus 512 cross 2048 plus 512. What was this whole number? Just this number? I mean, okay, whatever it is. Now the last layer, FFN is over. What about this linear one? So here your, how many outputs do you have here? 5 and 2. So this linear is going to receive how many? 5 and 2 and do what? Softmax. Softmax over mod V. I have no idea what is their mod V. So what is the sum of this you do? Huh? So each training batch contained a set of sentence pairs containing approximately 25,000 source tokens and 25,000 target tokens. Okay. So what is my linear going to be? It is 512 cross 25K. Because they say each training batch contained a set of sentence pairs containing approximately 25 source tokens and 25K source tokens and 25K target tokens. So, if you have 25K target tokens here, right, your softmax will compute a distribution over 25K numbers. So, if this is 512, this particular parameter matrix has to be 25K cross 512. Okay. So, do that. I hope I am doing it all right. So, linear, what was that? 25,000 cross 512. Okay, give me the total number now. So, everything until here, whatever you have got until here, it should be multiplied with 6. What is that? 22 million. Okay. So, that gives me 22 million. And what is this thing? Huh? Huh. Hmm? 12.8. This gives me 12.8. Okay. Now add all these three. This whole thing gives me 35 and what was here? 16.8, 52 still. 65. So, we are still off by 12.5 million. So, because you have what? 25 tokens at the target and 25 tokens at the input. So, the another 25K cross 512 will come from there. See, what you are going to do is, here the thing that I was saying, I am not unsure, I am not sure. So, here every 512, for every token you have 512, right. So, every word is 512 dimensional, and how many tokens are there total? 25K. So, this embedding matrix is going to be of size 25K cross 512. Adding all this up gives you 65 million. Okay. So, at the input here, every word is 512 dimensional, right? How many total tokens? 25K. So, 25K into 512 is the size of your embedding matrix that you also learn. So, that gives you another set of 12.5 whatever that parameters, and the total sums to 65 million. Okay. So, how many we had in so this was, so I mean, even though it's okay, but it is, so the total thing is 16.8 plus what was the other thing, 22 point, point only 22 plus 12.8 into 2. What is this giving me? So roughly this. I think it has some more. No, so yes. No, what are, there are some things we are missing too. In softmax you will have so many biases, 25K up there, okay, and for embedding matrix also you will be having a lot of biases there too. Am I still missing something? But no, we are talking about transformer. No, we are not talking about BERT. Right, so questions here now. Questions here. Questions? Because else we are done with transformers. So is this okay with everyone? कहीं पे कुछ गड़बड़ नहीं की क्या मैंने? कहीं पे कुछ गड़बड़ नहीं की क्या मैंने? So सो आज के लेक्चर में बहुत कुछ है मेरे पास एडिट करने को, ये बहुत पेनफुल काम है. हाँ भाई, एक बार लेट अस मेक श्योर वी आर नॉट डूइंग एनी मिस्टेक एंड देन वी गो. So you learned these word embeddings, right? What will be the parameter size here? Roughly 512 cross 25K, and I will have to go and check whether whether today's statements are correct or not. So it is 25K cross 512, and then we have 8 cross 3 cross 64 cross 512. Then we have 512 cross 2048 cross 512 plus 2048 plus 512, 0 here. Then we come here. Here we had. So okay, what about word embeddings here? Because they are for my source language and this is for my target language. Right. So we are having extra 2.5 million. How do we take care of that? So you can take your notebooks out again. Right. So you see what I am trying to say here? What will be the parameter size here for embedding matrix? 512 cross 25K. हाँ? सॉरी, तुम खाना ही खाओ, तुम खाना ही खाओ. What is 25K? 25K is by tokens on both sides, source language as well as the target language. Okay, so we did 25K cross 512 because those many word embeddings we are learning. Here we have a softmax over my vocabulary. So I have 25k cross 512. What about this guy? So now see here, these weights here and these weights here, they belong to the same vocabulary, target language. So you share these weights, they are not different. If I remember it right, here you multiply it with under root D model, okay, but that does not change the number of parameters. So the number of, the embedding matrix for this guy as well as for this guy is the same. So that's why we don't add this extra 2.5 million. Then we come here, what was this? 8 cross 3 cross 64 cross 512 0. Again 8 cross 3 cross 64 cross 512 0. Same things, okay, same things get repeated. So again, but jab itna kar liya to let's, so this is 2048 cross 512 plus 2048, then 512 cross 2048 plus 512, and then we come to this final linear layer which is 25k cross 512, and then you take softmax. How many parameters here in softmax? How many parameters in the last layer? So softmax does not have parameters, okay, so 0 parameters here, and you are done. You can go for lunch. So we are done for today. Say that again. You mean to say this 512 can be different? You can do whatever you want. So if you want to take 512 here, 1024 here, nobody stops you. Sorry? हाँ. नहीं. So you will have to take care of your numbers and parameters and multiplications, right? But nobody stops you from having 512 here, 1024 here. How will you handle that? That depends on how you are doing things, your imagination and all this, right? But in principle, nobody stops you.